As we all know, Kubernetes is becoming really popular in terms of hosting your applications. And with this modern type of compute environment, uh, the complexity has been driven out of the application into the environment. So what I'm going to show you in the next 5 minutes is how can you quickly monitor Kubernetes top to bottom, which is the infrastructure, including the Kubernetes components and the application supported atop that infrastructure. Uh, I obviously am going to use a lot of different tools and techniques to be able to walk you through how I was able to monitor the complete environment in less than 15 minutes. In this video, I'm simply going to give you a walkthrough of the monitoring outputs and the type of environment I used. And in the next video, I'm going to show you how I was able to monitor it in terms of the steps and the deployment techniques and even the simulations I used for generating load. All right, so let's dive into it straight away. Right. So before I explain to you how you can monitor Kubernetes top to bottom, I'm going to firstly walk you through my environment. For this particular video, I'm using 4 different desktops on my MacBook. The first screen here is basically to emulate the load. Now, I know I could have used load generation applications like JMeter, BlazeMeter. I didn't have the time and energy or the intent to use any of those tools. So I'm just simply going to use terminal or bash-led script to generate that load. The second screen here basically has the application that I'm using for this demonstration purposes. The application has 3 microservices components. Firstly, the shop front, where you can pick a few products. Secondly, the product catalog, where all the information surrounding the products is stored. Thirdly, a stock manager, which basically keeps track of the inventory. And the product catalog and the stock manager also connects into a database, H2. The next screen is my GCP cloud ecosystem. So I'm basically using GCP console from console.cloud.google.com. And here you can see I have a bunch of pods already running in place. In order to create problems within my Kubernetes environment where applications are just kind of floating around, I'm going to deploy a few more applications to create resource contention. And rather than using the CLI to be able to find out what those problems are, I will be using the 4th tool here in my environment, which is New Relic. So this is New Relic Health Map, which is a correlation between the application performances together with the infrastructure performances. So essentially, these are the few tools that I'll be using for this demo. All right, so next up, let's look at the monitoring solution here. But before I take you into a flyby tour of the monitoring solution, let's generate some load. To generate some load, I'm going to copy the URL here together with the port, and then I'm going to run some simple script like this. That's my first script. Run. Second. I think I've tested this before. This roughly generates 87 to 89 RPM, requests per minute. So right now, I'm pretty sure the application activities have kind of triggered. So let's look at what this dashboard view gives you as a Kubernetes administrator, as a production support engineer, or even as a developer who develops application on Kubernetes. and deploys application in your own namespace, which could be a development namespace. So here in this first map, I can see that there are already some critical violations in place. And these are based on the custom alert conditions that are targeting the application performance and the infrastructure performance within a Kubernetes ecosystem. So here it's saying that my product catalog application is not running. And I could easily toggle this view to look at my application performances on a per host basis. So notice none of my applications are currently hosted here, which is why you don't see a related application icon here. And if you like your cloud tags to be used for grouping your applications in a logical way, I am leveraging some simple tags like container, app name to be able to group my critical production applications together. And I'm using a simple host name tag to essentially create another filter for all my GCP worker nodes in a cluster. If I take you back into my GCP ecosystem here, I'm using a cluster of size 4, which means I have 4 nodes in my environment. Let's validate that quickly. And yep, so all of my nodes are in ready state. And I'm going to once again have a look at my pods, which are obviously being used in the deployments in terms of hosting the application containers. So by this time, I think the load is already kicking in. Let's look at the second view, which shows you how your microservices kind of talk to each other. So this is a perfect use case for using a monitoring pattern like a request flow map. And I'm just going to expand my request flow map. And here I'm able to see, notice the throughput here is pretty high. And it's obviously creating this new trend because of the simulations I'm running through my terminal screen. And if you go back in there, if I am seeing a lot of load on a particular microservice, I can kind of expand them like this and see which particular microservice is not behaving in terms of the typical baseline performances. So I can see here the trend is changing in terms of the performance for this microservice here. So let's drill into this app and see which particular transactions are changing in terms of the performance trends. Now, we all know that averages kind of suck because they skew the outlier performances. So in New Relic, you're also able to see whenever there is a new load trend, what is the impact of that new load in terms of the 99th percentile performance for that particular microservice or application. And without spending any other time, I want to see, as I generate that load, which particular service within my microservices architecture creates maximum degradation or contention. So here, this is our distributed tracing UI. You can simply filter by things like, error is equal to true, or you can even type in your transaction name. So if there is a GET API within your transaction, you can filter by that GET call transaction. And then you have obviously a lot of these transactions towards the tail end of this scatter plot. But you can also sort by the worst performing transactions here in terms of transactions that use the full flow of microservices architecture, which means they have 3 microservices participating in terms of completing that transaction. You can also sort the transaction by the root duration, as in how much end-to-end time was taken to complete that transaction. And you can also go into the history to kind of see which particular transaction in the history was the slowest. You can then click on one such instance and expand all of those spans in a single view like this. And pretty soon, as this application continues to get monitored by the New Relic service, New Relic will automatically start showing you prescriptive information on which particular span is not behaving. And it looks back 6 hours into the history of the application. But if you scroll down here, you can also perform some manual investigation, like how much is a particular span taking in terms of processing the transaction flow on the critical path. And then if you want to investigate on your SQL queries or your H2 stock select transaction specifically for this API transaction, you're able to investigate the query that got executed. You're able to see how this query performs on this host versus other hosts that might be used in terms of making up this application. Here, this is a single host application, so you are not able to perform host outlier in terms of average query time. And same way, you have a throughput host outlier facility here. I'm going to click into attributes here to be able to see how this particular database transaction was made up. So what is the DB name? So DB name is testDB. The duration of the select statement was pretty slow. I'm sorry, it was pretty quick. So this is not at all a culprit, but you're able to investigate on a span level. Now, the second part of the video, I'm going to take you into the infrastructure side of the view, and how can you as a product support engineer or even as a Kubernetes engineer understand if infrastructure becomes a contention for creating 5-star user experiences.